There you go.
That was a surprise. Andrew Martin. I'm Professor of System Security at the University of Oxford. And I was trying to decide what to say in this topic, but I think, why am I involved in ManySecured and other things seemed very relevant. And I suppose I read a lot of academic papers. I hope perhaps you don't have the misfortune of reading a lot of academic papers, but for every one that's a breakthrough, wonderful idea that you can immediately see the application of, there's a dozen that seem to be sitting in the corner and you think, well, how will that ever change the world? That's inevitable because that's the filtering process, and there's got to be a lot of academic work in order to find the good stuff. But I suppose I'm more interested in translational work, to borrow a phrase from the medics, how you take research and look at how it works in practice, or how it can work in practice. Perhaps that's the difference between science and engineering in this context. And so ManySecured is about a bunch of insights that I've been working on for years. I've been working on secure boot for 15 years, I think. But our first talk beautifully illustrated why the theory is one thing, but the practice is another. And bringing all of those things to bear on something like the ManySecured and then looking at what that means for a router in practice helps to ground all that research and also generates new research questions. And likewise, we started looking at the kind of analytics that we just heard about and how to go from what are essentially some quite mundane ideas about counting things and knowing what's there, but looking at how it works in a particular practice, a particular context. And to me, that's rather more interesting than another dusty paper that doesn't go anywhere. So contributing to those kinds of things has been the reason to get involved. And now we're looking at secure networking by design, a new project that follows on. And again, that's about translating some very conceptual ideas that come out of a university to the east of Oxford that we don't tend to name, and how to make that practical in a real product or in what might come close to a real product. I don't know how far we get with that, but because it's one thing to write the paper, it's another thing to do the work, and you only get that real engagement by sitting closely with people who've got product ideas and making them happen. So again, those people in Cambridge wrote about security engineering a long time ago. That's what I'm interested in making practical.
Right, thanks very much, Andrew. Michael, would you like to go next?
Sure. Does it work? Yeah, good. So you can learn more about me. I have a talk this afternoon where I talk more about what I do, or one specific aspect relating to trust and trust anchors. So I mostly write reference implementations of IETF security specs. And it's real engineering in a real sense. And actually one of the things that we're forever trying to do at the IETF is engage operators, so real ISPs who have real problems, okay, and who often are afraid to write code. And we're trying to bring them in as essentially representative customers of what we're trying to do, so they can tell us what actually really doesn't work in practice. At the same time, we have this ongoing up and down relationship with academics who want to dust off their dusty papers in the corners and say, well, I had this wonderful idea in 2008, and I still don't understand why no one loved it. And that becomes a kind of a cycle of a certain amount of people say things like, well, it failed in 1993, so it's going to fail now. And the reality is that maybe we actually need to come back and ask, why did it fail in 1993? Oh, because RAM cost $5,000 per byte, and now RAM is essentially free, and it would be a wonderful idea. And that doesn't always happen. And we in the kind of engineering community, we often don't read the papers, and we don't know what's going on because, well, it's unclear how it applies. But as you said about secure boot, I think secure boot is a wonderful, wonderful thing. And all of the last slide in that talk is actually what I'm talking about this afternoon, because there's all of the other things around secure boot, like does the CEO keep the key in a USB key on his desk? And I'm sorry to say that's probably more true than we actually want to admit. And actually, there's actually a real significant and serious security process around that. If you think about it, you need to ship a vulnerability. You like to ship it, comes in on Friday at 3 p.m., and you realize that, I don't know, you're Boeing, and your fleet of 737s will get grounded if you don't ship it by Monday morning, and the CEO's out fishing. What do you do now, right? Secure boot has just shot you in the foot. You could have done this without secure boot, and I'll bet you that there are organizations where there's middle management that basically go out and lynch secure boot because it now costs them a vulnerability. They had to wait for something to happen. And I think that that's really contingent on us to realize that it's not enough for us to come out with wonderful security mechanisms that are perfect in every way, but are completely impractical to deploy. And so I think that's a really important thing, that we need to go forward on this there. And the other, Nick and wherever it was, the fellow talked about false alarm rates. And I can tell you that in most enterprises, the alarms are off. And they stay off because if they turn them on, they can't get any work, nothing happens because the alarm rates are so high, which raises the question, why even test for things that you're not going to fix, right?
Thanks, Michael. Peter Shearman, would you like to take your turn?
Sure. So Peter Shearman. So I'm head of innovation for CISCO in the UK and Ireland. My team is responsible for our participation in projects such as ManySecured. That's an interesting point, Michael. I won't name who it was, but one of our engineers who said, "Oh no, the customer's turned off all of the alarms. How many are they getting a day? 10,000. Yeah, okay, no, that's fair enough then. But we've got to be smarter. But actually, that is one of the reasons why we were really interested in looking at ManySecured. When I think about zero trust collaborative analytics, the way that CISCO has looked at security and identity within its own networks, within things that it can control and its own parameters, you see a lot of the techniques that we're talking about here within ManySecured being applied in that domain. When you think about the way that we are now doing multi-factor authentication and things like that with the individual and with device and so on, and looking at context and behavior as part of the way that we're doing our providing security. And when it's within our control, that's great, right? And we're pulling in all the various bits of network intelligence that we can in order to make that work. But the reason that we need things like ManySecured is that when you get down to concepts like IoT, actually this is a multi-agency problem. This isn't something that CISCO has the ability to fix within its grasp. My team has looked at this challenge and the secure boot problem a number of times over the 10 years that I've been inside CISCO. And I remember one of my first conversations with our security engineering was, well, look, we do a really great job of securing the data when it gets to our network. Right, but what about the bit before that? Well, no, we do a really good job of securing it when we get to our network. Okay, so we don't do that bit. And increasingly but we have to find a way to make that work. And that has to be collaborative. And where we've got this approach of building up our context and understanding of intelligence in the network, we need to be applying those concepts collaboratively to the things that aren't part of our core network, and hence working on things like zero trust with ManySecured.
Right. Thank you, Peter. Nick, I've left you to last just to make sure everybody else got their third.
I'll try and keep it quick.
Well.
Right. So the unwritten need behind the way the system's designed the way it is really comes, to some extent, my background's AI, data analytics. I see I can see why it's needed in this area. I can see why it's essential, but you've got two really big problems. The state space of activity and devices is absolutely phenomenal. It's absolutely huge. And all of the stochastic AI, ML type methods, we don't have enough data to be able to train them. We just physically don't have enough data. It's impossible to get access to other data. But then another way of collapsing the problem is to collapse the state space. And so underneath what we're doing in ManySecured, sort of trying to tackle that problem from two angles. One, create an ecosystem where it's easy and practical to share device behavioral data at scale. That's fundamentally what you need, because if Vodafone sees something flagging on their network, they need to be able to pick up that signature and pass it over to someone else quickly and easily. That is collaborative analytics. The other thing that we need to do is reduce the state space. And the problem is when we talk about IP addresses, I mean, basically everything I was waffling on about in my presentation about types is really about collapsing the state space. It's all about taking individual phenomena and collapsing it into a set of rules. A lot of what John was doing, what we're showing, was collapsing an enormous set of behavior into a finite set of rules. But if you look behind it, certainly when he was looking at if you looked at the data on the internal network, what did you see? You just saw loads of IP addresses. Those IP addresses might have been set the same device. So if you have the ability to collapse those phenomena, those IP addresses, into devices of that type, you collapse the state space again. So it's all a very long, protracted, convoluted, really complicated piece of engineering tasks to achieve those two principal objectives. One, make it easier to share the data such that we can detect stuff. Two, add more intelligence to the system, collapse the state space such that the anomaly detection problem becomes more tractable.